Good afternoon, meteorologist Mike Linden here. We are awaiting official confirmation from the National Hurricane Center for Hurricane Ian to make its second landfall close to the Charleston, South Carolina area as a Category 1 hurricane. I am joined by meteorologist Matthew Cappucci back from his trip in Southwest Florida. We will get to Matthew in just a moment, but first I want to take a look at the latest track because again, Cappucci and I have been kicking back and forth wondering when it is that the folks at the National Hurricane Center are going to call this landfall. Just a couple of minutes ago, they pushed out an advisory saying landfall was imminent. So we are here to walk you through it. As it stands right now, Ian is a Category 1 hurricane at 85 miles per hour, moving at roughly 15 miles per hour. So that's about double the speed of which it moved through Florida. We'll zoom out a little bit here. You can see that right now it is making landfall to, it seems like, to the north and east of Charleston, South Carolina, pushing northward as it continues to weaken overnight tonight and into the weekend. It's wild to think that it is October. But looking at the track here, if I zoom on in for you here, initially it seemed that the center of Ian would go over Charlotte, North Carolina. It seems like while Charlotte will still see rainfall, the center of the track is likely to push to the east of it through the Greensboro area. As Ian continues to work its way northward, pushing into the Roanoke, Virginia and Lynchburg area. So that's, of course, where Virginia Tech University is. And at that point, it seems likely, in the National Hurricane Center, it has confirmed the fact that it's quite likely that we will see Ian dissipate at that point. So again, landfall is imminent for, I should say, the second landfall is imminent for Ian here, just to the north and east of Charleston, South Carolina. One quick thing, though, that I want to bring up, Jack, if you can pull up this graphic here that I have prepared on the WSI machine here, with the angle of approach for Ian as a Cat 1 hurricane. Remember, the winds are really just a small part of the story here. What you really need to check out are the storm surge numbers, because with the angle of approach, with how shallow things are along the southeastern coastline, I mean, Charleston, South Carolina is known as the low country for a reason. And look at all of the storm surge that's likely to inundate these areas. Anywhere where you're seeing red is upwards of 9 to near 12 feet of storm surge. And then look how far inland things go. With all of these little channels kind of coming in off of the Atlantic, you're very likely to see, again, all that water getting pushed into these low-lying areas. And even though some of these communities here along the waterways may not have storm surge color here, it is quite likely that you'll still get some really nasty conditions on top of the fact that it is just pouring rain for folks that live along the southeastern coastline here. I'm going to jump over to the tropical satellite imagery here and zoom in a little bit. Actually, I'll zoom out for a second because I want to draw this. Of course, with the way that these storms rotate in the northern hemisphere, they rotate counterclockwise. So you just have these big bands of rain coming in off of the Atlantic and just smashing in to the coastline. That stretches from all the way in parts of North Carolina all the way down into even some parts of northeast Georgia. So let me jump on over here and I'll show you the how much precipitation that we have seen on the ground. And it's quite a lot here. Let me grab my pointer tool here and we'll tap on Charleston. That's roughly 5 inches of rain over the past 24 hours, about 3.2. A lot more as we get up here into North Carolina, but all along the coastline, we're seeing anywhere between 1.5 or so to near 5.5, almost 6 inches of rainfall, and those amounts likely to be a lot higher here as those outer bands continue to smash in to the southeastern coastline. So I want to bring in meteorologist Matthew Cappucci, who of course was chasing Ian as it made landfall in Southwest Florida at a Category 4 with winds at 150 miles per hour. Cappucci, we're glad to have you back. Of course, things were a little dicey there with the lack of cell service. And of course, it's just a big mess down there in Southwest Florida, as we've seen some of Aaron's drone video. And of course, you were there as well. What was your experience like?
I gotta say, it's good to be back in studio. You don't realize until you do something like that it's a luxury to wake up and eat a warm breakfast and take a shower and have a roof over your head. You know, my trip was understandably a little bit dicey, but that's kind of how all forays into these higher end storms are. One thing that really stuck with me was just how kind people have been every step of the way. I mean, it's one thing to be kind of outrunning, evacuating from a storm like this. It's another thing to be willingly driving into it, yet they were so grateful for meteorologists to be there, for the folks who were forecasting, emergency management officials, and really even after the storm, everybody was helping each other. And you know, I've seen this before in natural disasters, but this storm just somehow seemed different in that everybody suffered some sort of impact, whether it be freshwater flooding, surge, destructive winds that may have ransacked their property. And yet everybody was just kind of all in the same boat. They're like, you know what? We're going to get through this. We're going to help each other along the way. It was really humbling to see. I actually wound up sheltering underneath an apartment building that was kind of high enough above sea level that I knew I wouldn't have to worry about surge. We dealt with some freshwater flooding too, but overnight while we were parked in our car having had a couple flat tires, we actually had the roof of the building ripped off, which was impressive to see and very distressing to see. Folks evacuated from the building itself to underneath in kind of a blocked area, not as susceptible to the wind, where they had vehicles kind of that they could just stay in overnight. But I want to focus on what's going on now with this storm. As you see, it's getting close to landfall. Let me move this over so you can see a little bit better.
Cappucci, it actually seems, Cappucci, it actually seems right now here, Hurricane Ian has made landfall. So breaking news, that occurred at 2:05. So it seems like it happened roughly 15 minutes ago, but it seems like they were just really trying to make doubly sure that was the case. So near Georgetown, South Carolina, sustained winds of 85 miles per hour with an estimated minimum central pressure of 977 millibars. I see some folks in the chat saying, wait a minute, this is the third landfall we're talking about for the continental United States. Of course, it did push through Cuba, but when we're talking about landfall in the continental United States, this is the second landfall. Of course, the first occurring in Cayo Costa, again, as a Category 4 hurricane, the same exact location and wind speed as Charlie, which is just stranger than fiction, really. But again, breaking news, Hurricane Ian has made a second landfall. That was about 2:05 Eastern Daylight Time near Georgetown, South Carolina, as a Category 1 hurricane, wind speeds of 85 miles per hour. Cappucci, back to you.
And Mike, quick question. What was that pressure, the central pressure?
977.
Wow. Okay. Thank you. So for the folks at home, we talk about air pressure. Okay. I want you to picture you are swirling your coffee, stirring your coffee in the morning. The deeper that dip is, the faster the fluid is spinning and vice versa. The reason being that fluid wants to fill in the dip. It wants to be nice and level, but the more you spin, the more that fluid is pushed out. So that balances the amount to which it wants to slush back in to fill that void. Same thing with a hurricane. You know, a hurricane or tropical storm, there's that void, that deficit in air pressure in the middle, meaning there's literally less air in the middle of the storm. Like we're kind of missing air towards the middle right here, but the reason it doesn't fill back in, all that air is swirling around and around and around and is pushed out by the centrifugal force at the exact same rate it wants to head back into the middle, which is why it's in something called cyclostrophic balance. You don't have to know that, but kind of a cool tidbit there. So let's talk about that pressure, 977. Ambient sea level air pressure is about 1,015 millibars. Don't worry about the units, but basically when we say 977, that means we're missing about 30, 40 millibars worth of pressure. In other words, we're kind of missing like 3 or 4% of the atmosphere's mass. The cool thing, so Mike said, I think 977. Here's what the Storm Prediction Center had. Awesome, thank you. Yeah, so here's what the Storm Prediction Center has as their mesoanalysis, meaning they're kind of taking data from weather observations, trying to plot it. And so you'll notice in the bullseye, 986 here. And you're thinking, is this wrong? Are they wrong? No. The 977 in the middle is so localized that it doesn't actually even show up on this chart. The reason for that being the fact that you have, lines somewhat close together like this, but notice the distance between the lines shrinks as you go towards the middle because that pressure gradient, the change in air pressure with distance, gets less and less and less and less because you're kind of funneling in faster and faster and faster and faster and faster. It's just like how, in your toilet, for example, when you flush, it's kind of gradual like this, and then towards the middle of that whirlpool, it kind of goes down fast like this. Same thing in the middle of a tropical cyclone like this. Now, I want to show you, as it's making landfall right now, a little bit north of it looks like Charleston, I want to show you the current observations. So we'll look at, let's say, printable surface observations. This might be a little bit tough to read, but we're going to go through it together right here. I'll put that on the, here we go, give you a little space to read it. And work with us. We're manipulating data in real time because we're data heavy folks. This is MyRadar. We like data. And it's the best way to tell weather stories. So basically, here's the deal. It might be tough to see at home, but these wind barbs show the wind direction. I'll call out a few observations too so you can read it. And then the number of kind of wind spikes shows sustained wind speed. So right here, just off the North Carolina, South Carolina border, we see temperature 78, dew point is 74, winds about 35 miles an hour, and a pressure of looks like 995, 991 here. Then towards the middle, right over here, where that thing's making landfall, it'll be close to that 977. So you see there's a sharp gradient. Up here, 998, 995. 991. So yeah, the center should be right around here. Notice a change in wind direction though. Over here, out of the south, over here, out of the east, over here, out of the north, over here, out of the west. There's that obvious swirl right here, and the apex of which is located just offshore of Charleston. We're taking, oh, awesome, oh, nice, we can take that full screen too. Great. Jeez, I'm so impressed. Like
it's up in full.
See, as you know, I'm always marveled by technology, and this stream looks great. You guys in the back, awesome job with this. Anyway, so a couple of things I want to point out. Temperature-wise, the reason this isn't like fully a hurricane anymore, of course it is technically a hurricane, but it's taking on some mid-latitude characteristics. Look at the temperature difference too. Over here, we're in the 70s. Over here, look at this. The top number represents temperature. It is 54. Looks like Greensboro, North Carolina. 54 a little bit northwest of Columbia. 57 over here, just west of the center. So we're dragging down cool air in the backside, warm, moist air riding up on the east side because this whole thing is spinning counterclockwise like this. Look over here, Outer Banks, 79 degrees right now in Hatteras. Dew point is 74. 80 right now down there, a little bit south of that, near the southern part, I think, Pamlico Bay. 76 is a dew point up there. So the air over here holding a ton of moisture, bone dry air in the backside. Look at Nashville right now, dew point of 36. So obviously, two completely different air masses. This thing's forming in between. So I want to show you a couple other really cool things right now, sort of identifying what the big setup is. You can see this unbelievably well on satellite. And Mike, I got to say, this is just an astounding satellite image that really captures everything you and I have really ever learned in a meteorology classroom. It's kind of coming to life right now. It's unfortunate that it's having this impact on people. So let's break it down for you. Obviously, the center circulation right over here. You don't really see an eye because this thing is sort of losing its tropical characteristics, plus the eye only really clears out in strong storms, okay? And this is a strong storm, but I'm talking like higher end hurricanes. Over here, we have what we call the dry slot. Ordinarily, if we're talking a fully symmetric tropical cyclone, we wouldn't have this much of a dry slot, but it's undergoing extratropical transition as dry air wraps in on the backside like this. So these little feeder clouds rushing in. Over here, you might have partly sunny skies, but here's the thing. You're near that minimum in air pressure, so it's still super windy. Onshore flow of, say, 50, 60, 70 miles per hour at times, even if you gust upwards of 80 miles per hour. So this whole area, partially sunny, but you're still getting that onshore flow causing significant coastal flood potential, for which reason I do want to show you just how bad that flooding could be. Roughly, Little River Inlet up towards really the Outer Banks, about 2 to 5 feet. For the northern half of South Carolina along the coastline, about 4 to 7 feet in a reasonable worst case scenario episode. Keep in mind, it's the king tide time of year, so tides this time of year are a little bit higher than the rest of the year given the position of key weather systems in the atmosphere and the lunar cycle as well. So again, north of the center, those onshore winds posing a bit of a problem. Over here, we have the bulk of the convection or the thunderstorm activity. And there's something called overrunning going on. What that means, we're wrapping cool, dry air in behind the storm. That's cool, it's dense, it likes to hug the ground like this, okay? This warm, moist air riding in the warm conveyor belt like this likes to ride up and over. The warm conveyor belt is actually way up here. So it rides up and over, and eventually that forces the air up into the atmosphere. It causes clouds, it causes storms, it causes thunder and all that heavy rain. It's kind of relegated back over here in kind of the comet head region like this of this sort of mid-latitude, sort of tropical system. Now, if we back up a little bit, and it might be tough to tell in this camera shot, so actually, or rather the satellite shot, let's see if we can take this full screen real quick. I want you to notice, I'm going to kind of wiggle my mouse so you can see it. I want you to notice over southeast Georgia, see these kind of ripples overhead? It's a little bit tough to tell, but like in this area right over here. Not the obvious ones, but sort of those secondary ripples at the high altitudes. Those are what we call gravity waves. Essentially, the storm has so much air rising in the middle over here that it's jiggling density layers in the atmosphere up and down, just kind of like ripples radiating outwards from a bobber in a pond, and that causes the surface to undulate upwards and downwards, and you see like gravity waves moving like this, so outwards from the center. Cool stuff there. You even kind of see one down here. You just barely make it out. Again, this is from the GOES East Weather Satellite, 22,234 miles above the ground. So, I want to talk briefly tornado risk if we can as well, Mike, then we'll toss over to you because that's something we have to consider with this. And I know you're going to cover rainfall and wind and stuff like that, and we'll kind of tag team back and forth. But tornado risk is there. The National Weather Service Storm Prediction Center has highlighted a level 2 out of 5 slight risk for severe weather for portions of the mid-Atlantic and especially the Carolinas. So roughly from the Virginia Tidewater down towards, looks like a little bit northeast of Columbia, mainly near and north of the system center. So again, here it is right here. Richmond, you're just kind of outside. Virginia Beach included, Newport News, Norfolk, Raleigh, mainly east of there. So it looks like Chapel Hill's included, Wilmington, North Carolina as well, and then towards the extreme northern South Carolina. Anyone in the yellow, that's a level 2 out of 5 slight risk for severe weather. And again, we put the tornado odds on here. You can see that kind of well. If we look, we actually had a tornado watch just issued for those areas. And keep in mind, this is a tropical cyclone related tornado watch. So tornadoes during tropical cyclones aren't like those big Midwestern style ones that kind of announce themselves, they get their hail first. No. What happens in scenarios like this, everything's kind of low topped, meaning the atmosphere is packing a lot of juice and a lot of punch in the lowest levels of the atmosphere. So you don't really get tall storms. You're likely not going to see hail or these huge towering thunderheads. Instead, we get these little micro supercells that are rather small, tiny little rotating storms that will have a quick hitting spin up or two somewhere across the area as they filter on shore. Now, where are those storms? Well, we go back to this. Actually, let's broaden out just a little bit if we can. And bear with me as I try to zoom in real time. All right, we'll try this again. Refresh the page. So here's what we'll do. We'll take a regional sector like this. Awesome. Oh, this is going to be some beautiful textbook imagery. Okay. Give us 1 sec while it loads. Oh, we have really fast internet here. I got to figure out who we use here and get them at home. Okay, so here's the deal. Here's the warm conveyor belt. Right like that. I mean, everyone can see this. Warm conveyor belt riding in like this. So as this moves in like this, notice how it's arcing. There's also going to be a change of wind speed and or direction with height called wind shear, especially in the northeastern quadrant of the storms as this landfalling kind of warm conveyor belt moves ashore. Any of these could be like those little micro supercells that have that tornado risk, really anywhere near and northeast of the center. You can actually really see that wind shear quite well in a real time. Let me see if I can slow it down just a little bit for you. And we're going to zoom in right over here. So, Mike, I don't know how easy it is to see, but at the lowest levels, we got clouds kind of fanning in like this. So almost due out of the southeast. At the mid levels, they're heading a little bit more north. That change of wind speed and or direction with height, wind shear, is causing any cloud that spans multiple levels to rotate. That's the concern with this afternoon. If we take a look again at Storm Prediction Center's mesoanalysis, which is our fancy way of kind of geeking out and just basically saying we put a bunch of fancy parameters on a chart for meteorologists to read, but we're going to read it all together, we can sort of see, again, here's sort of the key area, but we can sort of see really well where that wind shear is the greatest. Wind shear, change of wind speed direction with height. Look, right near the coastline as this landfalling warm conveyor belt moves ashore, plenty of shear to work with, and also plenty of juice, CAPE, convective available potential energy, where these two overlap right near the coastline. So I don't think you're going to see tornadoes, 100 miles inland. I think a lot of landfalling waterspouts possible today, especially along the coastline of North Carolina. And lastly, I do want to check real quick, see if we can get some low-level helicity. Where effective helicity? Let's see. Helicity is basically saying, where's our support for a rotating updraft? And if we look, we see helicity is obviously maximized nearest to the center of that tropical cyclone. But keep in mind, where's the juice? The juice is mainly offshore here. So that's why I think the best overlap right near the coastline. So really anyone, say Wilmington over towards Hatteras this afternoon, there will likely be a few tornadoes, mainly after about 3 o'clock, I'd say. We're kind of maximizing daytime heating. So, Mike, we got a lot of hazards to deal with. I know rainfall has been an issue too, surge, of course, and that wind, my goodness, it has been blowing a gale out there.
Right. As you've been chatting, Cappucci, we actually had the velocity up as we're looking along the southeast coast there, and there is some rotation in the atmosphere there. Of course, if we take the app here in full, Jack, we'll be able to show it. There's a ton of data coming in from that, I believe it's the Myrtle Beach station there, and you can see right to the east of the cone, of course, for folks out there that are looking at this going, this doesn't look anything like a normal radar. Well, this is a velocity product, whereas normally you would be looking at reflectivity, which of course a radar sends out a beam. It reflects off of the vapor and the water molecules that are present in the atmosphere, sends that return back to the beam, and that is how precipitation is shown to you at home. What the product is I'm looking at here is velocity. Green representing winds going toward the radar site, which in this case is that radar site it's right here near Myrtle Beach. Green is representative of winds going toward it. Red is representing winds going away from it. There's a ton of data coming in, so bear with us, folks, that this is loading in on its tiles. Yes.
I'm so sorry to interrupt real quick. Any chance we could actually switch to Morehead City, the next radar up the coast?
Yeah, let's do it.
Cells right there that are rotating pretty well, and I think it'd be a great way to show folks this awesome feature we have in the MyRadar app. So let's see if when we are to Morehead City. Yeah, okay. So look just northeast of Morehead City, and again, we kind of load things in titles, but we have so much data coming in. So what we're going to see, yeah, look at that little red against green northeast of Morehead City. So green is wind towards the radar. If we go east just a little bit, yeah, it's taking a second to load on my side, but if we go a little bit east of the radar, green is moving towards the radar, red is moving away. And I was actually looking east. That one, I mean, that was east. I'm talking like a little, yeah.
Aha,
so
I see it. Oh, yeah.
Yeah, the one between Oriental and Atlantic. And that signature, I mean, you will see it on screen in just a moment. Yeah, right there. That's a pretty robust signature, and honestly, you know, Mike, I wouldn't be surprised if this thing goes tornadic soon, and we have a lot more of those couplets moving ashore. And the other interesting thing, when we switch to reflectivity, we'll be able to sort of see the classic hook of that storm. So what we're seeing right now is obviously velocity. When we switch on over to reflectivity, that shows us how intensely the rain is coming down and any precipitation, and you'll be able to see kind of an arc on the backside.
Oh yeah, there it is.
Trying to trace like a classic hook echo. So we would not be surprised if the National Weather Service in short order issues a tornado warning for that part of North Carolina. Again, you know, rotation's been pulsing up and down, but it just kind of shows you how many of these things will be moving ashore this afternoon, one after another after another. So Mike, you know, a great day to, you know, if you're new to the MyRadar app, you want to learn some stuff, just explore radar, because there is a ton of stuff today. And we give folks a lot of the data, and, you know, anyone who wants a crash course in weather, that's our stream right now, where we're teaching folks how to use the app.
Cappucci, this is likely to be, I mean, if it is something that does indeed touch the ground, it could very well cross over the water here, which certainly goes to show people my time when I worked in Kentucky, when I would speak to folks that were living in the mountains, they were like, they would say, we live in the mountains, there's no tornadoes coming here. Well, you can ask the people that live in West Liberty about the EF3 tornado that touched down. Gosh, that was, I cannot remember the year right offhand here. I believe it was 2014.
March 2nd, I think it was March 2nd or 3rd, 2012.
Yes. Okay. Right. Of course, it hit the. Look at you, the encyclopedia. It of course hit a school there. None of the kids were there, unfortunately. But again, if you've never been to that part of Kentucky, it is very mountainous, and for folks that live outside of, you know, the more traditional tornado alley, or shoot, even lately along the Gulf Coast, where we've seen a ton of huge, very powerful, violent tornadoes. Tornadoes can occur anytime, anywhere. Really in any place. Most often they occur here in the United States, just based on our topography. But yeah, I mean, this signature here that Cappucci pointed out here, working its way through the Outer Banks, you'll see it in just a moment. In fact, I'm going to pause it here and we'll just jog right to it. Right there. That's what he's talking about. So when you start to see the signature of the colors kind of being within one another, that is indicative of rotation, as we touched on before. The green, in this case, winds going toward the radar, red representing winds going away from it. So when you start to see, as I just move it a little bit here, when you start to see that kind of signature, the colors kind of within themselves, for one, they stand out for sure, so it's somewhat easy to spot here on the velocity scan. But this again is indicative of rotation, not of a guarantee that a funnel has emerged and a tornado is on the ground. But this is certainly a good indication again for folks that there is rotation present. I've yet to see a tornado watch issued here. There is, of course, a tropical storm warning in place for this part of the world, but there is no tornado warning here issued just yet. But that is what you would call a radar indicated tornado. I mean, tornado warnings are issued quite frequently during severe weather events. Again, it's not a guarantee that there's a tornado on the ground. You'll hear a stronger wording, right, Cappucci? A tornado emergency when you're talking about a tornado being present on the ground. You have ground truth as well to verify that. Another product here within the Pro Radar pack that we can take a look at is the correlation coefficient. Now, for those of you that have never seen this product before, it is a big mess upon first viewing, but this is an incredibly helpful product that will show you objects being potentially lofted vertically into the air. If we were talking a strong tornado and, an EF3 or above, you might even see the presence of what's called a debris ball on reflectivity and on correlation coefficient, which would indicate that there is debris being lofted vertically into the air. That is not the case in this sense, but in fact, if I jump back to velocity, we'll find that spot again. There it is. I'm going to pause the radar right on that period, and we will switch to the correlation coefficient. Oh, it looks like it jumped on me there. So again, if there is anything there, it's quite weak all told, but just another example of a cool product that we have available in the app. We're adding new stuff every day here. I mean, we have the Echo Tops, which shows you how tall the clouds are, the vertically integrated liquid, which will show you hail cores. So much cool stuff for you to nerd out on. But let's zoom back out here, and we're actually going to jump back to the radar site here in near Myrtle Beach, and there again is Hurricane Ian. Now, for those of you that are just joining our stream right now, welcome. I'm meteorologist Mike Linden, joined by meteorologist Matthew Cappucci, and we have, at least at this point, we have confirmation from the National Hurricane Center that Ian has once again made landfall. This is going to be it, folks. This is the final landfall of Ian. If this thing somehow emerges along the East Coast, strengthens once again, and makes landfall, I don't want to speak for Cappucci there, but that would really surprise me if that were to occur. It does not seem like that is going to happen here. But again, as a Category 1 hurricane, I'm going to zoom in on the landfall location, that being Georgetown, South Carolina right there, making landfall just short of 2 o'clock, or just after, rather, 2 o'clock, 2:05 Eastern time to be precise, as a Category 1 hurricane with winds at 85 miles per hour. And for you weather nerds out there, and we know you're out there, 977 millibar central pressure. It is expected that we will see Ian continue to track its way northward through South Carolina, crossing over through South Carolina into North Carolina, just to the east of Charlotte there, pushing northward through Greensboro, so up and through the mountainous part of North Carolina, before once again working its way toward East Tennessee, parts of West Virginia, and into Virginia, as well as a tropical depression, weakening at that point. It is, at least from the latest advisory from the National Hurricane Center, all indications point to Ian weakening at this point. And remember, warm water is where a hurricane, a tropical storm, a tropical cyclone, that's where it wants to be. It does not want to be over land. So for those of you that may not have taken many geography classes, I mean, there's not much wide open warm water here in East Tennessee, West Virginia, and Virginia that's going to help this storm continue to live its life. So it is very likely at this point we will see it dissipate and then get pushed off to the east. Okay, so as we do this, what I want to do is bring in Matthew Cappucci, who, of course, was there for landfall of Hurricane Ian. And I think you've got some graphics there behind you here. We'll get to those in short order here. But once we're done with that, I want to show people some of the video that Cappucci was able to feed back to us. We can take a look at some of Aaron Jajak's drone footage that he shot there as well. I'm sure you've seen us share it on social media. And then for anybody in the chat here that wants to answer any question or ask us any questions, we are here standing by. Cappucci, go ahead.
Yeah, so Mike, one question real quick. Is there any way, I'm noticing another really geeky, really cool feature on radar again. Is there any way we'd be able to take the, gosh, what radar is that? I believe that is the radar between Charleston and Savannah.
Yep.
KCLH, I'm sorry, KCLX.
Yep. Got it.
So when we do that, if we do the per station radar, and Jack, we can throw that up in perhaps full screen. I want to talk through a feature, and it is really a very neat feature. So we'll pull that up in just a second. Here we go. Okay, let's put that in motion. Something really neat is happening. So for starters, look at the back edge of the precipitation. That's a sign that dry air is wrapping behind it, because notice how sharp that cutoff is. You go from probably inch per hour rainfall rates over, looks like central North Carolina, to next to nothing. And then you see that little thing, that little line west of KCLX. What that to me appears to be a gravity wave. So really, this whole storm is producing so much in the way of like undulation, or really has so much air moving up inside it that it's sending out a ripple horizontally off to the west. And that ripple is kicking up precipitation in that little yellow line right there, which is so cool to see, because that's actually propagating away from the storm, like radially outwards, which to me suggests it probably is a gravity wave. Even as the storm is pulling off to the north-northwest, it has that wave kind of kicking out off to the west, which is just Really neat stuff there. Anyway, a cool science tidbit. Let's go back to the big board right over here. I have a few graphics to show you just to kind of talk about sort of the future track of Ian, where it's going, what is next with it as we put those maps up. I have this one here to show you, and again, we come out to my monitor full screen. Perfect. So here's the deal. This thing, making landfall right now, it's going to continue moving northwest at about, say, 20-ish, maybe 30 miles an hour. Might start to curve north a little bit more. As it does so, yeah, it stays between 980 and 990 millibars, meaning it's still kind of a tropical storm for the most part as it moves inland. It may last until decently close to the Virginia border or as a tropical storm before it kind of weakens, fades, falls apart, and thereafter, there's just this wedge of cool, dry air after the north and west that says, nuh-uh, you're not coming farther north, and it boots it out to sea. Now, here's the thing. Once it gets out to sea again, Ian is the storm that has overstayed its welcome and does never want to leave. Eventually, it's going to go out to sea. I would not be surprised if it actually re-intensifies into a named storm, like a tropical storm, or probably not a hurricane, but at least a moderate tropical storm out over the open ocean. So, you know, Mike, this storm will never quit. The impacts we saw the other day were quite extreme, and honestly, we're done with this storm. The public is done with this storm. We have like 48 hours more of this storm being in the U.S. Then it's a fish storm, and frankly, goodbye and good riddance.
Yeah, and of course, for folks that have been asking, I've seen this question as well, asking if the name will be retired. That decision is not made for a while. We will soon see if it is retired. Of course, a large portion of that, or a large factor that goes into play there are, of course, the damage and unfortunately the fatalities as a result. I'm going to pull up some, what am I trying to say here? Trying to pull up I think I have it right here. Here we go. From ABC News and Ginger Z here. Unconfirmed and still counting, 21 people have died in this storm. So we will see if that number continues to climb. Cappucci, you were there. I mean, you were there for landfall. You were there for the aftermath of it. I'm going to pull up this video here. This is of the Eyewall, you said, passing through Englewood, Florida. I mean, gosh, look at that wind-driven rain. Holy cow. Take us through what it was like to be there for this Eyewall as it passed overhead, and I'll try to work our way through the video. I want to hear what you have to say about it.
Yeah, so this was actually the western eyewall of Ian as it was pushing to the northeast. So we kind of got the backlash of it. Initially, we were in the former eyewall, and usually the first eyewall is the worst because the second one, you have dry air wrapping into the backside. I think this storm was unusual in that it swirled all the dry air around. Some of it kind of encroached ahead of the first eyewall. So the first eyewall, we got gusts 80 to 100. It felt like a Cat 2, didn't feel like a Cat 4. Then this eyewall came in, the one you're seeing right there. And I've got to say, this was probably my most intense sort of core punch for a hurricane. And it definitely surprised me in that I was expecting, hey, I went through the first half, the second half should be a piece of cake. And no, this thing had teeth. It was mean, it was brutal, winds gusting 110 to 120 miles per hour over that area. The other thing, too, notice how much water was in the periphery of the roadway, too. All that you see there, that's not surge. Initially, we were worried it was, and we were trying to get out of Dodge, but that was actually freshwater flooding from about 15 to 22 inches worth of rainfall there. At one point, we got to flooded roadways, and we, of course, did what any responsible person would do, and we sat there for a second, thought, can we do this? No, we should not do this. Back up. You know, it sounds cliche when we say turn around, don't drown, but honestly, it's something you never want to mess with. It only takes about 8 to 12 inches of moving water to float a vehicle, which in conditions like this could quickly become fatal. We talked about that number of 21 people who have perished so far. And Mike, I hate to sort of adopt an uncharacteristically grave tone, but I got to say, I think that number is probably off by at least one order of magnitude. What I mean by that is, I wouldn't be surprised if we wind up with 100 or more fatalities. And these are just sort of the raw numbers, because keep in mind how many areas are isolated, how many areas have been impacted by surge, how many areas we simply can't get to yet. Going 36 hours after landfall, if not more, it's incredibly distressing. Also keep in mind, too, Florida has an aging population in this part of the state. We have a lot of folks who need medications, who need resources, who need supplies. And so excess mortality is going to be another factor here, too, meaning not the direct impacts of the hurricane, so like wind, surge, whatever else, but sort of the secondary and the tertiary effects of Folks can't get to where they need to go. Folks can't get the proper nourishment. It's extremely distressing. It goes to show you that Mike, a hurricane is not a 2-day disaster. This can be a disaster that lasts months or years for the people impacted. And one of the tough things that we grapple with as scientists, and that I certainly do too, when this is all over, I get to fly home. And it's such a feeling of guilt almost to be able to fly home, know that I have a place to go to at the end of the day when most of the people with whom I interacted don't. Their home is in shambles, and it's tough to carry.
Cappucci, I'm going to pull up an image here in just a moment from Sanibel Island, where part of the causeway has just completely collapsed. As it stands, as of right now, the only way in and off of Sanibel Island is by boat or by plane or helicopter. You physically cannot drive a car to and from Sanibel Island. I'll pull up that photo in just a second. Check this image out, folks. This is of the tornadoes from Hurricane Ian as it made landfall. This is from the 27th to the 28th across South Florida. Of course, we've talked very often about the way that hurricanes rotate, remember? Counterclockwise. Yep. So, of course, you saw a lot of those tracks, some of them quite long, in fact, upwards of an EF2 intensity. This guy here, just to the north of Boca Raton. So quite a few tornadoes from Ian thus far. I'm going to keep scrolling here down our Twitter feed. We've been posting a lot of video here. This one here, actually from Port Canaveral. More help is on the way to Southwest Florida. It was yesterday that the governor dispatched 100 portable cell towers as well as 100 engineers to help with the bridge collapses there. So help is there now, 300 truckloads of food. How about this one, Cappucci? These are the river gauges here across Central and South Florida. Anywhere where you are seeing a purple dot, that is indicative of major flooding. The red color there, indicative of the moderate flooding. Orange, representative of minor flooding. But again, the storm making landfall kind of right around here at the bottom of our image, and you can almost see the real track of where the heaviest rainfall was. So that was something that we really tried to make known to folks, that just because the center of this storm is not passing overhead of you, just from the sheer amount of rain from how big this storm was as it worked its way through Florida, flooding, certainly a major issue. Let's take a look at this video here, Cappucci. I think that you said these folks were from South Africa, if I remember correctly. These folks here kind of trudging through the water. Take us through how you met those people.
Yeah, so what wound up happening was that my vehicle, I was trying to get to a safe location, got to a safe location. I had about another 2 miles to go and was waiting for one of my friends to sort of shuttle me the last 2 miles, because we wound up losing 2 tires thanks to unfortunately debris and everything else in the roadway. One of the hazards when you're chasing a storm, something always goes wrong. But that's kind of how these things go. Anyway, these folks had a chicken restaurant that happened to be right next to the Winn-Dixie out in Rotunda. And they were walking by. They were just honestly not sure what to do because everything of theirs was in shambles. So they're kind of walking up and down the neighborhood. We struck up a conversation, and they said the Walmart down the street has cell service. And I knew I needed to get information to you guys, information to my folks, just let everyone know I was all right. And they said we all went to Walmart because they had messages to send too, and then they dropped me off at my hotel. But these folks were some of the nicest people I've ever met. They fled to South Africa due to political unrest and civil unrest about 2.5 years ago, and they said they came to Florida because they wanted a climate that was nice and rather tranquil. They opened up this business, and they've loved it here. They have a couple friends who live here, and they said they had seen hurricanes on TV. But what struck them was how long in duration it was. But I got to say, this couple and their son did everything right. They stocked up on food, they stocked up on medications, preparations, gasoline ahead of the storm. They relocated from the beach, where they have a home on the water, to farther inland, where they actually rode out the storm in their restaurant. They brought a portable mattress to press against the windows. I mean, Mike, there are a lot of folks who I think are sort of used to warning fatigue, or sort of, we'll say a hurricane's coming and the track might wobble, whatever. These folks did everything right, and it was very heartwarming to see. Not only did they do things right, but they were the first people there to be like, hey, do you need water? Do you need this? Do you need that? And I'm a scientist coming into this from outside. I brought my supplies and everything, but they were so eager to give in any way they possibly could. And, amid disaster, it's really heartwarming to see the triumph of the human spirit, especially down here in Florida.
So you mentioned, of course, they moved to this part of the world 2 years ago. I mean, that was the reality for a lot of people that moved to the west coast of Florida from the Fort Myers area all the way northward to Tampa, St. Pete. I mean, more and more people are moving there every single day. Even in spite of this, we will continue to see a ton of people moving there because it's a beautiful place to live. The water is very warm. The Gulf is gorgeous, right? And people will continue to move there. But this is what we've spoken about, that leading into hurricane season, anytime you have any of these tropical cyclones that get caught in the Gulf, I mean, it's almost as if all bets are off. I mean, we were watching this storm. We saw the greater factors at play that could have limited its intensity and its strength. I mean, this thing was 2 miles per hour off from becoming a Category 5 hurricane. And that happened really, really quickly. Let's keep looking through some of your video here, Cappucci. How about, let's keep scrolling here. This is right before the eye arrived. Walk us through here, your video from Punta Gorda. I'm going to bring up the audio so Jack just know maybe to adjust it as he speaks.
Awesome. And there's a bit of a lag, so remind me what video that was?
This is in Punta Gorda here as the eye arrived, snapping those power poles, as you mentioned.
Oh, yeah. So it may be tough to see, but again, on the left side, you can just barely see that power pole is actually destroyed sort of in real time in the video. We were having gusts about 100 to maybe a little more. Yeah, right there. It snapped, and it quickly snapped. It was dangling. My chase partner had said, put the vehicle with the emergency brake on. He was worried that the wind would shake the vehicle. And I said, no, I want to have it in reverse, my foot on the brake, ready to go in reverse in case we have to dodge debris. We were located under a cement overhang, so I was very comfortable with where we were position-wise. But you look at some of the damage there to a mobile home community. That was actually inside the eye when I got that video. And here you see more Eyewall video right there with just how low the visibilities were with sheets of rain whipping in. Mike, one thing that struck me with this hurricane was how much lightning there was. Ordinarily, we see very little in the way of thunderstorm activity in these higher-end tropical cyclones, especially towards the middle, because thunderstorms require vertical instability or upward motion to get going, whereas in hurricanes, we ordinarily see just much more horizontal wind, not much vertical oomph. In this case, we saw such rapid motion upwards in the eye that pinpoint lightning strikes were so numerous, it was comparable to a summertime thunderstorm. When my buddy and I were driving through the Eyewall, the last thing we expected was lightning to strike something about a quarter mile away. Aaron Jack said he almost got struck by lightning about 100 feet away.
Yeah, he said the same thing, Cappucci. He said the exact same thing, that the sheer amount of lightning, it's unlike anything he's ever experienced before in his life chasing.
Yeah, I mean, it's satellite images. And when we look at the GOES 16 stationary lightning mapper, essentially something that can track lightning from space, we had what we call an enveloped Eyewall lightning signature. Basically, the EEL is one ring of lightning around the eye, and anytime you see that, that's essentially a precursor to intensification or an indicator, a harbinger, that it's maintaining its beastly strength, and indeed it was. And another really bizarre thing we saw with this cyclone, the potential for hail to have fallen just offshore soon before it made landfall. It's just unbelievable. We had so much vertical ascent, 50,000-foot tops. I mean, that's what you see in a summertime thunderstorm over the plains. And yet, 50,000 footers producing pea to dime-size hail offshore over the Gulf of Mexico in a hurricane, in one of the warmest storm environments you can possibly see, is really unlike any storm I can remember in recent memory. It bore some shades of Michael back in 2018, and we saw how anomalous it was meteorologically. And one of my old professors said, it said something along the lines of, you forecast anomalies, expect anomalous results, and we saw certainly some anomalous results with just how much devastation there was.
Cappucci, I've got it pulled up here. The moment of landfall at Cayo Costa as Cat 4 here with the geostationary lightning mapper turned on. Can you see it on your end?
Yeah, so it'll be about 2 seconds.
Okay, all right. So, gosh, I mean, again, as Cappucci brought up, I mean, for one, you can really see the stadium effect of the eye there as it made landfall. But just again, those are lightning strikes in real time, folks. Thanks to thanks to GOES satellite, as Cappucci mentioned before, 22,000 miles up. It's way up there. It truly, I mean, I could watch this loop again and again and again. It truly is amazing to see. Of course, Dr. David Ruglicki talked about the mesovortices around the eye. You can see that happening here. It's a GIF, so I can't zoom in.
Yeah, so I actually experienced the mesovortices in the eye. So for folks at home, a mesovortex is essentially a way for the storm to flux or to move angular momentum inside the eye. And what on earth does that mean? So picture outside the eye, we have the eye wall, that ring of extreme winds wrapping around the eye, okay? Extreme winds, we're talking like 120, 130 plus miles an hour. There's so much momentum, so much velocity in that curvature, that wrapping around of the winds, that you have a lot of angular momentum. However, you go into the eye is essentially an oasis of calm, this weird insular location where the air, for the most part, is unperturbed, not moving. Now, imagine you have this bizarre balance of extreme angular momentum and nothing right next to it. The hurricane is going to naturally want to dissipate some of that angular momentum into the eye. To do that, it can't just push it straight in because, of course, there's so much rotation around. So it just kind of curls, these mini, what we call mesovortices, that flux that momentum, kind of wrap that wind energy into the eye and dissipate it. But what that does is contort the eye wall a little bit, make it kind of clover-shaped or make it a little bit weird and wonky. So realistically, what that means for folks on the ground, once they get to the inner eye wall, it's not a clean transition where you go from crazy wind to calm inside the eye. You might go from crazy wind to gradually lesser wind to calm. Then a mesovortex wraps around. Suddenly, you get a bit more of that eye wall energy fluxed in or pulled in. You get a crazy gust to 110, then nothing again, then maybe one more gust to 110. So you get these rapid pressure and wind fluctuations on the inner edge of the eye wall. And actually, what I'm going to do real quick is see if I can pull up an image that I saved from the MyRadar app that I'll have behind me to sort of point out what that looks like on radar, because our app, again, does a great job of really showing real-time conditions during the storm, and you'll see momentarily as I find the correct image. Just one moment. But what that feels like on the ground is you get your ears popping because there's so much of a quick, oh, here we go, it'll load momentarily. There's so much of a quick change in conditions that if we take a look at this, so here's the eye as it was preparing to make landfall. Notice how it's kind of scalloped on the western side right here. Our app doing a phenomenal job showing that in high resolution. If we look a little bit more closely, you can see, Mike, these are those mesovortices. Each time, you're calm right here, you wrap in an area of intense wind. You're calm again right here, you wrap in another area. So that's why, as this rotated through, our ears were popping. We were getting those crazy irregular gusts. It was very staccato. Imagine you're just banging cymbals, banging the drums back and forth. Finally, we got into the eye. The eye was murky and overcast. It wasn't fully calm. And the reason it wasn't fully calm in my mind, there was so much moisture near the surface, trapped beneath an inversion. Or you had warm temperatures aloft, slightly cooler beneath it. I think all that moisture got caught up in there below radar level and was forced to precipitate, causing mist. But I saw a few hints of bright skies. Aaron Jajak said he saw the sun briefly, never any blue skies. But Mike, to be in the eye of a Category 4 hurricane is a surreal experience.
And Cappucci, we are going to take a video here that we've showed a couple of times of you, sir, trying, it seems like desperately to hold on here. We're going to let it run and let past Cappucci kind of walk us through what it was like to be in that eye wall, and then President Cappucci can take over and chat about what that experience was like. So here we go. Take it away.
Yeah, so we were in the eye wall at this point. I believe I was over the bridge. We're going to wait for 1 second so I can see that clip on my end, just because we have a bit of a lag behind. But here you see, yeah, I have the goggles on. The reason being twofold. Number one, debris. If you have any splinters, any shards, whatever, moving at 100 miles per hour, that can quickly become a big problem. And number two, there's no way other to say it than it almost feels like you're drowning in real time, because the precipitation in the air, you're getting like 3 or 4 inch per hour rainfall rates, just crazy rain rates, but the droplets are so fine that they just permeate anything. And so at this point I was leaning, I was trying to hold on to I believe my vehicle nearby, and we were seeing winds gusting 80, 90, 100, 110. It was difficult to stand up. When I started having, I did the math once a while back, when I start having difficulty standing up, mathematically should be around 75 or 80 sustained. And you'll notice, I mean, not only is it tough to stand up, but there are times I really have to brace against the wind. Between that, all the other indications, solidly gusts over 90, likely over 100. But yeah, those goggles came in handy. I've been through hurricanes like this before, where the rainfall rates and the wind were so intense that water was actually blown through the window crack, or like through the edge of the doors, which I mean, it seems like something out of a horror movie that the water can seep into your vehicle even with everything watertight shut. Hurricanes find a way. They are unforgiving.
Cappucci, it truly was a storm that I think you won't certainly forget anytime soon, and it's certainly a storm that I won't forget anytime soon. But what I'd like to do here is to jump back into the app for those folks that are just joining us here. We're probably going to be wrapping up here somewhat soon. Cappucci planning on going back to Southwest Florida to speak with some folks there as the cleanup continues. But as we look right here at the radar imagery here, we'll pop on the high-def radar for you folks. So as it stands right now, Ian is still trudging its way northward there. It made landfall about an hour ago, coming up on that exact hour, roughly 2:05 Eastern time near Georgetown, South Carolina, 85 miles per hour. As it continues to push its way northward here, expected to weaken to a tropical depression as the weekend continues toward Greensboro there, and then continuing to track its way northward up near Roanoke and Lynchburg when all is said and done. A lot of rain coming in on those outer bands from Ian, stretching from Charleston, South Carolina, all the way north and eastward into Norfolk, Virginia, pushing into Richmond as well. In fact, if I zoom out even more, even spots in D.C., Cappucci's stomping grounds, very likely to be dealing with some heavy rainfall here from those outer bands as they continue to swing in toward the eastern coastline. So again, a lot going on with Hurricane Ian. Again, it has made its final landfall in the United States along the southeastern coastline there after making landfall just a few days ago as a Category 4 hurricane. But Cappucci, is there anything that you'd like to mention to the folks here watching in the chat before we say goodbye?
Yeah, most definitely. This is something where the entire East Coast is feeling the effects of Ian somehow. Let's take a look real quick at this incredible satellite image. I say incredible. It's scientifically beautiful and also very distressing. So here's kind of what the deal is right now. This thing looks like a comma swirl, and indeed it's undergoing what we call extratropical transition, feeling the effects of the jet stream and kind of ingesting dry air behind it. So yellow is showing very little water vapor in the air. Here's that dry slot punching through right here. Ahead of it, we talked about that warm, moist conveyor belt wrapping in from the south. Just really a textbook image like this. You have cooler air up here, then all this, this is a convection, the shower thunderstorm activity. Over here, look how sharp that backside is. If you're in like Columbus, Ohio right now, and you look up, you will see a perfect line across the sky. So actually, Mike, I'm incredibly curious if anybody over the, say, the Cumberland Plateau of Tennessee, of eastern Kentucky, go up to like Columbus, Ohio, or even the western end of Lake Erie, if anyone is there and can see this perfect line in the sky, please tweet us photos. I'm genuinely curious. I want to see what it looks like. Up here, the other cool thing, this is all outflow or cool air exhaust at the high levels pushing away from the storm. Notice how it's kind of fanning up and away. And what that means is you have cirrus clouds, kind of high, thin, wispy, diaphanous clouds with ice crystals. So there's a good chance those hexagonally shaped ice crystals in these clouds here will split the sun's rays, rather split the white light in the sun into its component colors. So you'll see a 22-degree halo around the sun. So just amazing stuff there. Again, here the green showing you where that convection, the heavy thunderstorm activity is dumping plenty of rainfall, more than they need, up to about 6 to 10 inches in spots. But really, this is a sinister symphony, if you will. It's symphonic, it's elegant scientifically, everything coming together to make a meteorological masterpiece, but also sinister because it is having potentially devastating impacts on people. So Mike, this storm's almost done in the U.S. anyway. We got another 12 to 36 hours to go, depending on where you are. But if you're on the western side, send us a picture of this, please. It's truly incredible.
Yes, we would love to see it. So you can see the social media platforms right above my head here on Twitter. If you tag us in that photo, send us a DM at MyRadarWX. We'd love to see it. We'll retweet you too. So again, you can see all those social media platforms above my head. If you're watching in the app, thank you very much. If you're watching on YouTube, smash that like button. It's that thumbs up there. Click on the subscribe button as well. Both totally free, and we would really appreciate if you do so. Click on the notification bell as well. That way you always know whenever we drop a new video or whenever we go live. And of course, we are everywhere nowadays on all of our social media platforms. We are also on TikTok as well. So follow us there. You'll see a lot of Cappucci there. And that's probably going to do it for our stream now. We still have lots more to cover here. Storm Chaser Aaron Jack is in town. We should be trying to figure out where he is going next. Of course, Cappucci, as we just mentioned, is working his way south as well to return to where Hurricane Ian made landfall as a Category 4 major hurricane just a couple of days ago. So again, thank you very much for watching this afternoon. We really appreciate it. Again, for the folks that live in and along the southeastern coastline, a lot of rain on its way for you guys over the course of the next 12 hours or so. So hunker down, be safe, and from all of us on the team here, stay safe and, of course, stay dry. We'll catch you back here in the next one.